You know, we put a ton of trust in the systems that run our world. Everything from AI to our power grids. But what if that trust is built on a really dangerous illusion? So today, we're going to dive into NoeticanLabs, a research lab with a pretty radical idea that we need to fundamentally rebuild our engineering foundations to create a reality we can actually truly rely on.
And it all kicks off with this simple but honestly pretty profound question. We use data for everything, right? To understand and control our world. But what if that data is lying to us? What if acting on it is like trying to navigate a huge city using a map that's just missing entire neighborhoods? You're going to end up completely lost.
So, that missing neighborhood on our map? Well, that's what NoeticanLabs calls the mirage of measurement. It's this fundamental flaw in how we see the world. And believe me, it has some huge consequences for the high-stakes systems we're all trying to build.
At the very heart of this problem is something called the hidden state problem. Think of it this way. Any complex system, anything at all, has a true, incredibly detailed reality. But our sensors, our models, they can only capture a simplified fraction of it. And that gap between what's really happening and what our data shows us, that's the hidden state.
And this leads us straight into a massive error in thinking, what the folks behind this call the core fallacy of modern control. It's this assumption that the data we have is the system. We build our models and make our decisions as if our simplified view is the absolute truth, completely ignoring everything that's happening in that hidden gap.
Here's a great way to picture it. Imagine you're looking at a satellite photo of a forest. It looks perfectly healthy. It's all green, right? But what that satellite can't possibly see is a disease spreading through the roots. That's the hidden state, and your data doesn't see it at all. By the time the leaves finally turn brown, it's way, way too late.
And this is where that gap starts to cause real problems. Imagine your system can only see the square shadow cast by this cylinder. So naturally, you build it to interact with a square. But the moment the light shifts, the shadow becomes a circle, and the system you built for a square just completely fails. That right there is what's called a projection-induced defect.
Okay, so if just observing the shadows on the wall isn't good enough, what do we do? Well, NoeticanLabs argues we need a massive shift in thinking. We have to stop just describing systems from the outside and start truly governing them from the inside.
And this is exactly the mission of NoeticanLabs. What they're doing is building the formal mathematical foundations for systems that can operate safely even when they can't see the full picture. The whole goal is to create a foundation that is genuinely trustworthy.
And wow, the difference between the two approaches is just night and day. The old way, shallow modeling, it just pretends the data is perfect, and when things go wrong, it tries to slap on a penalty after the fact. The new paradigm, governed dynamics, it acknowledges that hidden reality from the start and builds in these hard physical barriers to prevent the system from ever making a catastrophic mistake in the first place.
So, how does this actually work? Well, it's all about creating what they call a lawful architecture. And this isn't about adding more rules and red tape on top of everything. It's about embedding the actual laws of physics directly into the system's design. The core of this is a framework called Coh. Probably the best way to think of it is as the operating system for this new governed reality. In a Coh system, things don't just happen. Every single change has to basically prove it's allowed to happen before it can occur.
Now this is where it gets really, really cool. This framework drags real-world physics right into our computers. Just like in the real universe, every action has a cost. Every change has to be funded by some resource, like energy or information, and it all gets tracked on a ledger. The system literally can't do the impossible because it doesn't have the budget for it. It all comes together in these 4 pillars. First, is the change legal according to the system's own rules? Second, is it funded? Does it have the resources? Third, is it admissible? Does it respect the hard limits of reality? And finally, does it produce a receipt that proves it was a valid move? You see, this shifts us from blindly trusting a system to verifying every single transition it makes.
Okay, this all sounds great in theory, but does it actually work? Well, let's take this idea and apply it to one of the hardest engineering problems on the entire planet: controlling nuclear fusion.
A fusion reactor is pretty much the perfect storm for the hidden state problem. You've got this superheated plasma inside, which is an unbelievably complex, high-dimensional reality. But we can only see it through a handful of sensors. So you're basically just seeing a faint, blurry shadow of what's really happening in there.
And this leads to 3 huge and honestly pretty dangerous uncertainties. First, you can never, ever perfectly guess the plasma's true shape.
Second, all the tiny little errors in your data build up over time, and that can lead to a sudden, catastrophic failure. And third, you can't even be sure if the action you're about to tell the machine to take is physically possible.
So what's the big deal? Well, the stakes here are insanely high. Misinterpreting the shadow on the wall inside a fusion reactor isn't just some small data error. It can cause the plasma to go unstable and slam into the machine wall, which can destroy millions of dollars of equipment in an instant.
Okay, so this is where the governed approach just completely flips the script. Instead of trying to guess the plasma's true state, the controller's job is now to enforce admissibility barriers. The question is no longer, what do I think the plasma looks like? The question becomes, given what I know for sure, what is a provably safe and physically possible action to take right now? Every single control signal becomes a certified lawful transition.
And you can probably see the implications here go way beyond just fusion. As our systems, from the global financial market to autonomous AI, get more and more complex and interconnected, the more they start to look like that plasma. The harder they are to see into, and the less they forgive our mistakes.
Ultimately, this is about a shift from writing rules to building realities. It's about designing systems that are safe not because we tell them to be safe, but because the very physics of their world gives them no other choice. And that is one powerful foundation for the future we're all building.